As he mentioned, I'm Mike Tutkowski. I work at a data storage company in Boulder, Colorado called SolidFire. I'm a full-time CloudStack developer, spending my time integrating SolidFire's feature set into CloudStack, and then also more generally helping to enhance the storage component of CloudStack. Just to kind of give you a little bit of understanding where we're coming from with SolidFire, we're a clustered scale-out storage system, a storage area network. We leverage entirely industry-standard hardware, and we're built from the ground up to support hard quality of service guarantees. So in this case, what we mean by quality of service is actually dialing in the number of minimum, maximum, and burst IOPS that you want on a volume-by-volume basis. And that's to distinguish quality of service from a more general tiered approach where you might have multiple, maybe 2, 3 tiers of storage, but the volumes that you create in that model are sharing IOPS in the tier that they're in. So you may be in a faster tier of storage, you may have more IOPS at your disposal, but in that model you're still sharing the IOPS and competing with other tenants, so to speak, in that environment. In our case, the idea is every volume is its own tier of storage. This works out very well in cloud environments where by its very nature it's multi-tenant. You don't know on a day-to-day basis what your neighbor is doing, if he's heavily utilizing the storage system or if he's not. You don't have to worry about what your performance is going to be on a day-to-day basis with the SolidFire SAN because your volume has a guaranteed minimum number of IOPS. A few more points of interest. It's an all SSD architecture. We use a lot of efficiency technologies such as inline deduplication, compression, and thin provisioning to bring the cost per gigabyte down to be on par with traditional disk-based systems. And another very useful cloud feature is that it has an extensive REST-like API, which is exactly what I use when I develop code for the CloudStack SolidFire plugin. I am leveraging the SolidFire SAN just as any other third-party vendor would do. It's a very extensive API, covers all aspects of the SAN. So, just to kind of, just not knowing how much experience level everyone in the room has with CloudStack, I just kind of want to dive a little bit into some of the details of how storage is set up in CloudStack currently, which would be the 4.2 release, which is in production, and also how things were before the 4.2 release, because 4.2 is when things in storage changed considerably. So this view here is how the system was set up prior to the 4.2 release. In this model, the zone level has our secondary storage, which is still true today. And then within zones, you have pods and clusters. Clusters are where primary storage was exclusively located prior to the 4.2 release. So a given host in a cluster either had access to local storage and or shared storage, but not storage at the zone level. In 4.2, that changed where at the zone level now you can bring in primary storage and have it accessible to multiple clusters. Just to kind of clarify the differences in use cases between primary and secondary storage. Primary storage, when we're talking about that in the CloudStack context, that is all about disks for running your root data and your data disks. A lot of random I/O as opposed to secondary storage, which is typically write once, read many times. It's a lot of sequential I/O, you store templates, ISOs, backups, information like that. So in our case, today we're talking about primary storage, storage for actually your root and your data disks. So primary storage, and what did this mean prior to the 4.2 release? Some of this is going to be review for people, but I'd also like it to, I think it's beneficial to stress how manual of a process some of this was before the 4.2 changes and the ability to actually integrate storage plugins into the CloudStack framework. So with primary storage prior to 4.2, as I mentioned earlier, it is for storing root and data disks. And this primary storage was exclusively associated with a cluster. So primary storage for one cluster could not be seen by any other cluster. Didn't matter if it was in the same zone or not. Primary storage in a cluster can be accessed by multiple hosts if it is shared, and that's true, of course, today in 4.2 as well. And depending on the hypervisor type, there's a lot of different ways in CloudStack to consume that primary storage. Our example today, I'll use Zen Server, but other common use cases would be with VMware, ESX, and KVM. And they all kind of consume the storage differently, and then we bring it into CloudStack differently. So this is the provisioning process pre-4.2, and this again is just to kind of compare and contrast with where I'm going with the 4.2 and post 4.2 releases. And this is just to illustrate again a very manual process that was involved, very static. So what happened here was if you were using a storage system like SolidFire, you would go off to that storage system, create your volume, your LUN, probably make it very large, because in the end, it was going to store the root and data disks for a lot of VMs. So you create a large volume. You then go into your hypervisor of choice. So if it's Zen Server, we'd go into Zen Center, and we'd create a storage repository to consume that iSCSI target. And if this were VMware, it would be a data store. At that point, you're now ready, after that manual process, to go into CloudStack and create primary storage that's based on that data structure from your hypervisor. So in CloudStack for Zen Server, you would specify that you want to use a pre-existing storage repository. Once that was all in place, and you've tagged the primary storage, which we can get into later if people aren't sure what that means, then you're ready to actually use that primary storage. And as you create volumes or you spin up VMs, that primary storage can be fair game to place the root disks and the data disks. The big issue for a system like SolidFire's is that we don't want multiple root disks and or data disks sharing one of our volumes. Because even though the volume itself has guaranteed IOPS, you might have picked 1,000 minimum IOPS or 10,000 minimum IOPS for that particular SolidFire volume. If you are still sharing that volume with multiple root and data disks, those are like mini tenants on that volume competing for the guaranteed IOPS of that volume. That's not a real situation to guarantee IOPS in the end. So what we're moving to, and what we've already done now in 4.2, is create a model in which volumes on the back end, in this case the SolidFire SAN, can be dynamically created as the need arises in CloudStack. So if you want to create a CloudStack volume, at that point in time that you attach that volume to a VM, the storage framework in CloudStack will kick in, invoke the right API calls in your plugin, and then it's up to your plugin to use whatever means it has at its disposal to go off and do work on its back end. In our case, we would go off and create a SolidFire volume. It would have a certain number of minimum and maximum burst IOPS, and now you have a one-to-one relationship between that data disk that you've just created and the volume that supports it on the back end. So whatever IOPS go to that SolidFire volume are exclusively dedicated to that CloudStack volume. So we're no longer sharing that SolidFire volume across multiple data disks or root disks. There's a very granular level of control now. So just kind of walking you through some of the traditional steps, and then we'll get into the plugin. Prior to 4.2, this is going through what I just discussed. The first step would be to go and create a volume on your storage system. In this case, it's a screenshot from the SolidFire GUI. And as you'd expect in most systems, you volume, you give it a size. And the unique area here for SolidFire is the area at the bottom where you specify the minimum, the maximum, and the burst number of IOPS. So the minimum is pretty much what it sounds like. It's a minimum. If you're running the system hard enough, it won't drop below that minimum number of IOPS. The maximum is an upper bound in most cases. If you are not actually using all of the maximum IOPS, if you're not running the system hard enough, you accrue credits, and at certain points you can burst above your maximum. So you could picture a boot storm or some other event that might be useful to burst above your maximum for a certain amount of time. So that's just some of the unique configuration areas here within this SolidFire volume creation. Another point of note here is the account field right below the volume name. So the SolidFire system is built to be multi-tenant in nature, so every volume that you create is associated with a particular account, and there's an extensive API that runs the entire SAN. You can query for statistics on account level, volume level, all sorts of ways of pulling information or making modifications to the system. And just to kind of stress again, that API, that REST-like API that the GUI itself uses, is what I use in CloudStack. So there's no private API that my plugin uses. I treat the CloudStack SAN just like any third-party vendor would. I don't have any special privileges in CloudStack. All right, so once, and again, pre-4.2, that was a manual step. We went over to the SolidFire GUI, or we used its API, we created a volume. The next step is to go over to your hypervisor. In this case, it's Zen Server. I'm using Zen Center, its GUI, and I'm creating a storage repository to consume that iSCSI target that I just created. We won't cover this in very much detail, but basically I pick software iSCSI for the type of storage repository. I provide the IP address of the SAN. So in this case, it's what we call the storage virtual IP address. The SolidFire SAN is a scale-out system, so it consists of multiple 1U storage nodes. You start around 4 or 5 nodes, and then you grow the SAN out as you need it. So you're not talking about a system where you purchase a whole bunch of storage up front. It just sits in your data center, consuming electricity and needing to be cooled. In this case, you start it as you need it, and then you grow it out over time, basically paying as you grow. So in this case, what happens is we have a storage virtual IP address. It's a floating IP address which all clients use to make their connections to the iSCSI targets. And that's what I'm using in the Zen Center GUI here. What happens here is you actually, the Zen server host will talk to this IP address to log into the target. And if it's successful, that storage node in the cluster will rebalance the iSCSI connection. It'll just use an iSCSI redirect, so the Zen server host will be load balanced out to another storage node in the SolidFire cluster. In this case, I'm actually using CHAP credentials, which is below that, and then just selecting the particular iSCSI target and the LUN that I want. For the SolidFire SAN, every iSCSI target just has a single LUN, so LUN 0, it's easy to pick that one. The bottom left is just my naming of the storage repository, which will be useful when we're actually in the CloudStack GUI. So I just called it SolidFire Gold. That's the name of the storage repository in Zen Center. And then in the bottom right, you can see that I've created the storage repository. It is in a Zen server cluster. All of the hosts in that cluster have access to that storage repository. So Zen server has some kind of a clustered file system. It's applied to that storage repository, and then it lays VDIs, virtual disk images, inside of the storage repository. So at this point, we're moving on to CloudStack, and we're actually consuming that storage repository. We're creating primary storage in CloudStack. I won't dwell on a lot of this too much, but the interesting point here is that I've referenced SolidFire Gold as the storage repository that I want to consume as primary storage in CloudStack. And then below that, I've also applied a storage tag that I called SolidFire Gold. Storage tagging, for those who aren't familiar with it, it's a way for you to associate data disks and root disks with some storage. So when you execute a compute offering to spin up a virtual machine, the root disk has to be stored somewhere. That compute offering has a storage tags field as well. And if any of the storage tags for that compute offering match one of your primary storages, that primary storage is fair game to use to deploy that root disk on. Same idea for data disk offerings. If you're going to create a data disk, there's a storage tag field. If I created a data disk offering with a storage tag field of SolidFire Gold, when it actually came time to execute that data disk offering, this particular primary storage is fair game to house that data disk on. So the main thing to notice here, I guess, is the SolidFire Gold is just being used for storage tagging, and I happen to use the same name when I created my storage repository, but they don't have to be the same. All right, what I just talked about a second ago, I'm just creating a compute offering, and I've kind of already covered the details here. At the way bottom, there's a storage tag field, and it says SolidFire Gold. So when an end user actually goes and executes this compute offering to spin up a VM, the root disk can be stored on the SolidFire Gold primary storage. You could have multiple primary storages that have that same tag. Any one of those would be fair game. Okay, so now let's get more into the newer stuff, and I kind of want to take just a quick moment to compare and contrast. On the left-hand side there, that's what we just referred to a moment ago. That is a model in which you create a really large iSCSI volume or some storage, and you house a whole bunch of root disks and data disks on that, say, SAN volume. Those volumes, those CloudStack volumes, the root and the data disks, they're competing for whatever IOPS they have. There is really no hard and fast quality of service in that kind of a world. The model on the right-hand side is where we're going to in just a moment. That is describing the one-to-one relationship that is really ideal for the kind of system that SolidFire is. So in this model, when we spin up a virtual machine, the root disk can end up on a single SolidFire volume. When we kick off a data disk offering to create a volume, that volume ends up on a single SolidFire volume. Whatever IOPS you specified for that volume, which can be collected through the CloudStack GUI or passed in through the CloudStack API, that is what you get. It is a guaranteed number. You don't have to worry about what other tenants on the cloud system are up to that particular day. So when I started down the path of writing a plugin for CloudStack, we had certain requirements, of course. The big one here was to be able to create a one-to-one relationship between SolidFire volumes and CloudStack volumes. So that one kind of went without saying. Additionally, I needed to have some way of passing in vendor-specific attributes to that plugin. So in this case, I needed to collect the minimum and the maximum IOPS, at least those two fields. And we'll see later, but we can actually collect that through the GUI. So as an administrator sets up, let's say, a disk offering, he's presented with additional fields. When he selects quality of service for storage, he can specify the minimum and maximum IOPS now for a disk offering that an end user can execute. The next thing we wanted to avoid here, we wanted to make this a very automated process. We didn't want to have CloudStack users writing their own orchestration logic. CloudStack does orchestration very well. Prior to the 4.2 release, it is actually possible, I did a bunch of research on this, it is actually possible through API calls to the SolidFire SAN, to your hypervisor of choice, and to CloudStack to establish a one-to-one relationship between a back-end volume and a CloudStack volume. It's extremely messy. There's a lot of work that's involved in that, and the plugin, which was implemented in 4.2, removes all of that complexity. Now it becomes very easy to make that one-to-one mapping. The final point here is that we needed the ability, it's kind of what I talked about originally, we needed the ability to defer the creation of that volume until the last possible moment. An administrator can't be involved in that process. Everything has to be automated. People are executing disk offerings as they need them. This whole process of creating volumes on the back end to support the newly created CloudStack volumes, it all has to be automated. There can be no admin intervention at all. So I won't go into too much detail here. This is an API call to CloudStack to create a storage pool in CloudStack. It is an existing API call, but as a 4.2, it's been augmented to allow the caller to specify the plugin that should support this particular primary storage. So what happens in 4.2, there's really two plugins. There's the default plugin, which if you look a few lines down, there's a provider equals SolidFire. The provider field is how you specify what plugin to use. In this case, I've specified the SolidFire plugin. If you leave this field off, or if you specify the default plugin, what you get is the behavior of CloudStack's storage component prior to the 4.2 release. So everything that worked in the 4.2 release for storage still works, but it's been wrapped up in a plugin, the default plugin. And that is to distinguish it now from other plugins like the SolidFire plugin, which you now, when you invoke this command to create a new storage pool, you can reference the new plugins that are available. We don't really need to get into a lot of the details here, but the URL field, that was a pre-existing field. This is your way to pass in vendor-specific configuration parameters. So like I mentioned, there's a storage virtual IP address. There's also a management virtual IP address. So when you send API commands to the SolidFire SAN, you don't specify a specific storage node in the cluster. You're referring to a virtual IP address, and that can float across the cluster. So if one of the nodes is being brought down for maintenance, everything is still up and running on the SolidFire SAN, and that management virtual IP address has now floated to another node. There's no outward interruption of service. And this is exactly how I access the SolidFire SAN. I use our regular management virtual IP address to send API commands, to create volumes, delete volumes. I talked about accounts that the volumes have to be a part of. I have to create accounts, delete accounts, all sorts of management activities. And I just am referring to the MVIP whenever I need to send those to the SAN. The SVIP that I referred to earlier, that's the same idea. That is used when I configure hypervisors. So Zen Server, when we created our storage repository, I need to automatically create a storage repository now in this new plugin environment. And so this is all happening behind the scenes. There's no user intervention. There still is a storage repository being built to access our SolidFire volume, but it's all being done behind the scenes. There's no admin interaction. So that's basically what that field is doing there. It's passing in a bunch of information to the SolidFire plugin to let it know how to communicate with the SolidFire SAN and how to configure access to iSCSI targets. A couple of other points of interest. You can actually pass in capacity IOPS and capacity bytes now. So in the past, what happened was you would create a large volume, and that was just a predetermined size. And whether or not you had any control over IOPS, that was sort of, well, it didn't exist 4.2, but the volume itself was a pre-configured size. In this case, we're creating primary storage that's actually based on a storage area network. It's not based on a pre-existing volume. So what I'm doing here is I'm actually telling CloudStack of whatever's available in this SAN, you can use 4 million IOPS. So maybe the SAN has 100 nodes, 7.5 million IOPS. I'm telling CloudStack, I give you permission to use 4 million IOPS and whatever, 2 petabytes or something like that. So that way, CloudStack doesn't have complete access to use the whole SAN to exhaustion. If you want it to, it definitely can, but this is just a way of constricting what CloudStack can actually do. It can only make volumes up until it hits that size, or it hits the number of IOPS that we said is a maximum. And if you need to update those numbers, there's another API command, update storage pool, which just allows you to make modifications to those settings. So just to kind of drill this home, I just wanted to point out that if you were to look in the infrastructure tab at your normal primary storages, this will just show up as any other primary storage will. So again, it's not a pre-sized amount of storage. It's a SAN, but it does show up in the infrastructure primary storage area, just like any other primary storage would. If you make 100 volumes on the SolidFire SAN, that will not get you 100 primary storages in this section. You still have just your one primary storage. Another area to note here, the scope, I think I was going to mention it a slide ago, but if you look on the right-hand side, the scope is at, in this case, the zone level. So what happens here is this particular primary storage, it's not associated with a specific cluster. It can be used by clusters all over the zone. So once you use this primary storage to create a volume for a particular cluster, that volume can later be, if it's a data disk, it can be detached from a VM in one cluster. It can be reattached to a VM in another cluster. So there's no limitations like there used to be that primary storage has to be confined to a particular cluster. I mean, obviously the only limitation there is if you detach a data disk from one hypervisor type that's got its own clustered file system, you can't attach it to another, but that really doesn't have anything to do with the SolidFire system in particular. All right, so just kind of giving you an example of how this works now in 4.2 and beyond when you create disk offerings, just as an example. It's the same kind of a dialog. So I've gone into the Service Offerings tab, and I've selected disk offerings. We click on the Add Disk Offering button in the upper right. This is all the way it is today. Every field is pretty much the same except for there is a QoS type. It might be very hard to see. Maybe it's, I don't know, around the middle up there. But there's three options. There's no QoS, which would be backward compatible with prior to 4.2. There is hypervisor QoS, which is rate limiting for KVM. And there is what I worked on, which is the storage QoS. When you click on the storage QoS in the drop-down box, you get a couple extra fields. You get the minimum IOPS and the maximum IOPS. You, as an administrator, can fill those values in. There's even an option, if this makes sense in your environment, it might make sense for some enterprise environments, that you can check a box that says, as an administrator, I don't want to specify the minimum and maximum. I want to let the end user who creates the volume specify the minimum and maximum. Obviously, got to be kind of careful with that. It wouldn't make sense probably in large cloud installations, but for some enterprises where you have control over your users, it might make sense. So that was the difference between the two dialogues there. One says admin define QoS. That's where the admin sticks in the minimum maximum. The other one is the admin just check the box that says custom IOPS. And that really is just paralleling. There's a custom size checkbox above it. And that was the same idea. The administrator could specify the capacity of the volume, or he could check the box and let the actual end user specify. And that has the same kind of problems. So, all right, there's nothing really groundbreaking to show here. This is just demoing that once you've created the disk offering, just like any other disk offering, these are just new properties on the disk offering. It shows up in the disk offerings table. I've circled the new fields. It just says whether it's custom IOPS and what the minimum and the maximum IOPS are, so it's easy for the admin to go back and refer to that if it's not specified in the description, which it probably should be, so the end users know what they're getting. Let's see. All right, so this is now from the end user's point of view. So no longer admin related here. This is the end user. He's logged in. He's going to create a volume. What's going on here is we're basically in the storage tab, like you would expect. We've gone over to add a new volume. And it's pretty much the two corollaries to what we were just looking at. You can select from the disk offering combo box, the disk offering that we just created, and then depending on how the admin set it up, either those IOPS were fixed, or on the far right-hand side, the end user can actually specify the IOPS. Once you've created the volume, at this point, the volume really exists in the volumes table in the database only. There's been no interaction with the plugin, so there's no API calls yet to the SAN. That comes at a later point here when the customer actually attaches the volume to a VM for the first time. At that point, the CloudStack storage orchestration system kicks in. It invokes the right API calls to the plugins. In our case, when we're told to create an object, we actually create an iSCSI target on our SAN. We specify the minimum, maximum burst number of IOPS, and that part of the plugin, its work is done. I've also had to go in, now my work is kind of twofold in a sense. I work on the SolidFire plugin to make these API calls, but that's not entirely sufficient because of the way CloudStack was built from the ground up to expect storage to be pre-allocated. So for every hypervisor type that I support, which is now Xen Server, VMware, and KVM, I've had to go into those hypervisor plugins, sort of plugins, and make them understand the distinction between pre-allocated storage and dynamically allocated storage. An example would be that for VMware, we never needed to create data stores in the past because that was expected. When you came to CloudStack, you came with a pre-created data store. Now we need commands to actually create data stores dynamically. We have to delete them, all sorts of activities like that. And that's all handled for you now behind the scenes, so it's completely automated. Let's see here. I know I'm probably running out of time. Just to give you a quick idea of what's going on the SolidFire SAN, once you've attached that disk for the first time, we've gone to the SolidFire SAN, we've created the volume, set the IOPS, and we can see in the bottom right here, just kind of looking at the details, the IOPS would be easily accessible through the SolidFire GUI or its API. I don't currently have the ability to make modifications to IOPS through CloudStack. I have plans for that, but it is entirely doable easily through an API call to make modifications to the IOPS of an existing volume. There's no downtime, there's no bringing the volume offline to do that. You can just make an API call and change the minimum, maximum burst number of IOPS on the fly. On the hypervisor side, I described this. This is now just kind of a visual. The storage repository will be created for you. And then within that storage repository, you're probably used to seeing multiple VDIs over time. That's because those are representing disks that are sharing that storage repository. In this world, a single storage repository will have just one virtual disk image for Xen Server. For VMware, what you'll have is a data store with a single VMDK file. And last slide. So I just wanted to point out a few notes here before I wrap it up. Yeah, I guess I actually already mentioned that first note. So it works very similarly with VMware. Instead of creating a storage repository and then a VDI within the storage repository, we create a data store and then a VMDK file within it. Let's see. The next note is just in reference to KVM. So for the 4.2 release, the plugin is all written, but it supports only VMware and Xen Server because of the overhead just involved with going in and making a lot of modifications to that plugin. So what's going on in the 4.3 release is that I also support KVM, and this is actually quite a bit different from the way VMware and Xen Server work. In this case, since KVM, we don't have really any native clustering going on there. What's going on is I updated the KVM agent to use a process called, a tool called iSCSI admin to log into our iSCSI target, and then it uses VirtIO to attach that target to the VM. Final thing here, hypervisor snapshots will be supported in 4.3. So this is not vendor-specific snapshots yet, but hypervisor snapshots. So let's say you create a 10 gigabyte CloudStack volume. In 4.2, that leads to the creation of a 10 gigabyte SolidFire volume, and your VDI basically takes up as much space on that SolidFire volume as it can. But there was no additional space in that SolidFire volume for you to take hypervisor snapshots. There was a lot of technicalities around why that had to be that way, but for 4.3, I've enhanced it such that you can specify, all right, I want a 10 gigabyte CloudStack volume, but I'd also like to have an extra 5 gigabytes for hypervisor snapshots. So if somebody takes a snapshot of a VM and you have a data disk that's on SolidFire storage, that can be snapshotted from the hypervisor's point of view, and that snapshot laid down within the same SolidFire volume. So yeah, I probably ran over a little bit here, but were there any questions?
Thanks, Mike.
Yeah.
When you say we are guaranteeing IOPS, right? Is there a way like user can see it? Like I'm guaranteed this number of IOPS at that point of time?
Sure. So the question is, how can the user see the number of IOPS that are to be guaranteed? So it depends if you mean like real time. There's definitely tools that we use in-house to run a volume to a certain, basically run the volume as hard as we can and make sure it's at least getting the minimum, but it should be going up to the maximum if the SAN can currently support that. So there's a lot of different tools that you could run on your own to do that. As far as just like looking in the GUI, we definitely specify for a particular volume what its minimum and maximum, and well, not the burst, but the minimum and maximum and what those should be. So there's no good point. There's no tool within CloudStack to actually monitor the IOPS. So that would be something you just kind of have to use your own tool if you just want to be convinced that you are in fact getting the IOPS that you expect. Yeah.
Another question?
The dynamic provisioning for disks. Is the dynamic provisioning for root disks?
That's a good question. So for the 4.2 release, we support data disks for Xen Server and VMware. For the 4.3 release, it's data disks on KVM. And I'm turning my attention for 4.4 to support root disks. There were definitely a lot more complications involved with template copying and all sorts of technicalities there. I'm starting down that path in 4.4.
Okay, thanks again, Mike.
Yeah, thanks.